Hello, this is Namisha Goswami. You are welcome in online series of machine design. So, particular internal combustion engine. So, in previous lecture, we have already seen that design of piston, function of piston, material for the piston, design of piston head, piston crown, piston fin. Okay, so that portion we have covered in previous lecture. So, in today's lecture, I will going to cover about the connecting rod. Okay. So, what is internal combustion engine? Internal combustion is engine where combustion of the fuel takes place inside of your cylinder. So, that is known as your internal combustion engine. So, components are for the internal combustion engines are cylinder, connecting rod and piston and crankshaft, right? So, these are the basic four components. So, here some strokes, intake, exhaust, compression, expansion, combustion, all these strokes will be takes place during the operation. Okay. So, connecting rod is connected from one end, it is connected with your piston and another end will be connected with your crankshaft. So, this is basic components for the connecting rod, and whatever amount of energy received from piston to the connecting rod. So, connecting rod transfer that useful work to your crankshaft. So, finally output we can obtain on your crankshaft. So, what is connecting rod? First function, what is the connecting rod? This question will be arise in our mind, right? So, connecting rod which is used to connect the piston to the crank or crankshaft in a reciprocating piston engine. Okay. So, this is connecting rod. Now, what is the function? Okay. What does it do? Means what is the function of the connecting rod? So, it transmits the thrust of the piston to the crankshaft, right? Or you can say that whatever useful work will be generated inside of cylinder will be transferred to the piston to the connecting rod, and that connecting rod will transfer that useful forces to the crankshaft. Okay. So, it results the reciprocating motion of the piston is transferred to the rotational motion of the crankshaft, and connecting rod is having the oscillatory motion, right? And crankshaft is having the rotary motion and piston is having the reciprocating motion. So, there is one chain or links are there from reciprocating motion of piston will be transferred to the oscillatory motion of your connecting rod, and oscillatory motion of your connecting rod will be transferred to the rotary motion of your crankshaft by using the useful work. So, this is the function of your connecting rod. Now, what are the different components by using that connecting rod is made up of? Okay. So, there is a small end, okay, so which is known as the portion of the connecting rod which is connected with your piston is known as small end, right? And the portion of the connecting rod which is connected with your crankshaft is known as big end, and shank portion, middle portion is known as your shank portion, right? So, you can see here, this is the diagram, small end, okay, big end and shank portion. So, this is your diagram, you can see in this diagram. Now, how does it function or how does it work? So, connecting rods are subject to two different type of the forces which are generated by the mass of the components and mass and fuel of combustion of the fuel. Okay. So, these two forces results in axial loading and bending. So, due to that forces, axial loading may be there and bending may be there. Okay. So, this is the function. Next is, so what should be the capacity of a connecting rod? Okay. So, a connecting rod should be capable to transfer that axial tension or axial compression, means tension and compression. You can say that pull, push. Okay. So, and bending stress caused by the thrust of the piston and by centrifugal forces. Okay. So, that should capable of transmit the all these forces. Okay. Now, what is the cross section of the connecting rod we will consider? So, there are the several types of the cross sections are available for the connecting rod. It may be rectangular, circular, tubular, okay, I section, S section. So what section we will prefer for the designing purpose, right? So for the low speed engine, generally circular section is considered, and for the high speed engine, generally I section is considered. So we will design the, in this lecture I will design the connecting rod by considering the I section for the high speed engines. Okay. Now, so connecting rod is a machine member which is subjected to alternating directed compressive and tensile forces. Compressive and tensile forces, right? So alternating forces may be there. Okay. So so how to design a connecting rod, because there are the tensile forces is there and compressive forces is there. So we have to find out which force is larger, either tensile or either compressive, right? So in connecting rod, compressive forces are more than as compared to your tensile forces. So these connecting rods are designed as a strut. Okay, strut is a portion which is having the large compressive force as compared to your tensile forces. Okay, so we will generally design the connecting rod by using the Rankine formula. Okay, so Rankine formula is used, so we have to consider the what are the end condition for the x-axis and end condition for the y-axis. So in Rankine formula, both end hinged we will consider for the buckling of the x-axis, about the x-axis, and both end fixed for buckling about the y-axis. So these are our consideration in Rankine formula, right? So when we will consider the connecting rod equally strong in buckling about both the axes, means buckling load in x-axis should be equal to the buckling load in y-axis. So you can see here, this is your I section I have considered here, right? So now, what is the design and construction? So according to Rankine formula, when we consider the both ends are hinged, so L is equal to L, means capital L is your length, equivalent length, and L is your length of your connecting rod. Okay, so buckling load is given by the sigma C A divided by 1 plus A L divided by KXX ka whole square, means this is about the x-axis. So sigma C is your compressive stresses, A is your area, A is your capital A is your area, small a is your constant, which values are different for the different material. Capital L is here equivalent length, okay, and K is your radius of gyration about the x-axis. Okay, so for the when we consider both end hinged, so capital L is equal to small l divided by 2. So we will put the value in the same formula and we will get this mathematical equation. Now next is L is here equivalent length of the rod, A is constant. Yes, so A is different for the different material. So A is equal to 1 divided by 7500 for the mild steel, 1 divided by 9000 for the wrought iron, and 1 divided by 1600 for the cast iron. So these values are constant for the different materials. Okay. Now A is here cross sectional area of the connecting rod, small l is your length of connecting rod, sigma C is your compressive, yield stresses, WC is here buckling load, I axis, IY your moment of inertia of the section about the x and y axis respectively, and KXX, KYY also radius of gyration of the section about the x axis and about the y axis respectively. So these are the basic fundamentals of the connecting rod. Now next is for connecting rod, when it will be equal in buckling about both the axes. So buckling load about the x-axis is equal to buckling load about the y-axis. So I will equate these two equations that we have written in previous slides. So you will get the k-axis square is equal to 4 kyy square. Okay, but here I is equal to moment of inertia is equal to area into radius of gyration ka whole square. So we will put this value in this equation. So you will get the Ixx is equal to 4 times of the Iyy. Okay. So this was the connecting rod. Thank you.